Good morning, students. We have been solving the second Roman of the 3B exercise of the chapter Parabola. We have already worked out 7 problems from the second Roman, and this is the 8th problem. The question follows like this. Two parabolas have the same vertex and equal length of the latus rectum such that their axes are at right angle. Prove that the common tangents touch each at the end of the latus rectum. This is the question given. So here the parabolas are not given. So let us take the parabolas to be y square equals to 4ax, x square equals to 4ay. So what is common in both these parabolas? These parabolas are standard forms of the parabolas whose vertex is at the origin. And for both of these parabolas, the length of the latus rectum is 4a and 4a. Same. And for y square equals to 4ax, the principal axis is x-axis. And for x square equals to 4ay parabola, the principal axis is y-axis. And x-axis and y-axis are perpendicular. Hence it is given axes are at right angle. So we need to prove that the common tangents touch each at the end of the latus rectum. See, this is the diagram of this parabolas. This is y square equals to 4ax. This parabola is y square equals to 4ax. And the focus is this. This is the focus, fixed point. So this fixed point lies on x-axis. Therefore, x-axis is the principal axis of y square equals to 4ax. And so the chord which is passing through the focus, therefore it is focal chord, and which is perpendicular to the principal axis is called the latus rectum. So L dash is the latus rectum of the parabola y square equals to 4ax. And for x square equals to 4ay, the vertex is still at the origin like y square equals to 4x, and so the focus lies on the y-axis. Therefore, the y-axis is the principal axis. So y-axis and this x-axis are right angles to each other, perpendicular to each other, and P dash is the latus rectum of x square equals to 4ay. This is the data given. Now we need to show that the equation of the tangent x square equals to 4ay at P dash is s1 equals to 0. This line we will be getting. And the equation of the tangent y square equals to 4ax at L dash is still s1 equals to 0. So S1 equals to 0 for this and S1 equals to 0 for this should be same, since it is a common tangent at the ends of the latus rectum. So this is the end of the latus rectum of x square equals to 4ay, and this is the end of the latus rectum of y square equals to 4x is what we need to prove. Solution: let the equations of the parabolas be y square equals to 4x, x square equals to 4ay. So let P dash be the latus rectum of x square equals to 4ay, and L dash P dash is the latus rectum of x square equals to 4ay, and L dash is the latest rectum of the parabola y square equals to 4ax. Be the latest rectum of the parabola y square equals to 4ax. Now, the equation of the tangent to the parabola x square equals to 4ay at p dash. Now, the equation of a tangent to the parabola y is x square equals to 4ay at p dash minus 2a comma a is s1 equals to 0. That implies x1 is equals to 2a into y plus y1. So x into x1 is minus 2a is equals to 2a into y plus y1, y plus a. So 2a gets cancelled. Therefore, this is minus x. If you transpose onto another side, this is x plus y plus a is equals to 0. This is a tangent to the parabola x square equals to 4ay at p dash, which touches the parabola. So this is the tangent. This touches to the parabola y square equals to 4x at L dash. To the parabola y square equals to 4x at L dash. That is a comma minus 2a. Now, equation of the tangent to the parabola y square equals to 4ax at one end of the lattice rectum L dash a comma minus 2a is s1 equals to 0. So the rotation of s1 equals to 0 for this is y1 equals to 2a into x plus x1. This implies y into y1 is minus 2a is equals to 2a into x plus x1, x plus a. So 2a gets cancelled. Therefore, this is x plus y plus a equals to 0. This tangent at L dash a comma minus 2a touches the parabola x square equals to 4ay at p dash, which is minus 2a comma a. Therefore, for the common tangent to the parabolas y square equals to 4ax comma x square equals to 4ay touch each end of the lattice rectum. Show that the foot of the perpendicular from the focus to the tangent of the parabola y square equals to 4ax lies on the tangent at the vertex. Let us suppose that this is the parabola y square equals to 4ax. This is y square equals to 4ax. Its focus lies on x-axis, which is s a comma 0. Let us suppose that this is the tangent. This line is the tangent to this parabola y square equals to 4ax. And this P is the foot of the perpendicular from the focus as a comma 0 to the tangent of this parabola. So this is tangent. So given equation of the parabola is y square equals to 4ax. The slope form of the tangent to the parabola y square equals to 4ax is y is equals to mx plus a by m. Y is equals to mx plus a by m. Its slope is m. Its slope is m. Now, the slope of a line which is perpendicular to this tangent is minus 1 by m, because this and this tangent are perpendicular. So, the slope of the line, the slope of a line PS is minus 1 by m, since PS is perpendicular to the tangent. Now, equation of the line PS having slope minus 1 by m and passing through S a comma 0 is, they have a point and a slope point form. Y minus y1 equals to m into x minus x1. So y minus 0 is equals to minus 1 by m into x minus x1a. So this is equals to minus x plus a. So my is equals to minus x plus a. So therefore this is y is equals to a minus x by m. So here y is equals to m square x plus a. So this is my minus my is equals to m square x plus a. Find LCM here by m. So m into m square x plus a. So this m on transposing, cross multiplying, then we get my equals to m square x plus a. So here this is 1 and this is 2. Solving 1 and 2. If we solve this 1 and 2, what do we get? This my is equals to m square x plus a is this line, and this my is equals to minus x plus a is this line. If you solve this line as well as this line, this is what we are getting, which is the foot of the perpendicular of S a comma 0 onto the tangent. So solving 1 and 2, that means m into y is a minus x by m is equals to m square x plus a. This is equals to m gets cancelled. That implies a minus x equals to m square x plus a. A gets cancelled. So m square x plus x equals to 0. Therefore, m square into x into m square plus 1 is equals to 0 to m square plus 1 equals to 0, m square equals to minus 1, m is equals to root of minus 1, which is not possible. Therefore, x is equals to 0. So, substituting x equals to 0 in this, y is equals to a minus x by m. Then we will get y is equals to a minus 0 by m. This is a by m. Therefore, the point of intersection of the tangent of this tangent and PS is the foot of the perpendicular from S a comma 0 on the tangent. So that is P is equals to a 0 comma a by m. So P 0 comma a by m lies on this P is 0 comma a by m. So this point of intersection lies on the y-axis. So which is the tangent at the vertex to this parabola y square equals to 4ax. Hence, the locus of P is x equals to 0. X equals to 0 is the y-axis. This y-axis is a tangent at the vertex of the parabola. Show that the tangent at one end of a focal chord of a parabola is parallel to normal at the other extremity. Let us suppose that this is our parabola, y square equals to 4ax, and this is our focus, S. So this is the focal chord. So P comma Q are the ends of a focal chord. So now this is our tangent. This is our tangent at this P, AT1 square comma 2AT1. And this is the normal. So this is the normal. Equation of the tangent at P AT1 square comma 2AT1 is yt is equals to x plus at square. So at P, yt1 is equals to x plus at1 square. So from this, y is equals to x by t1 plus at1 square by t1. T1 gets cancelled. Therefore, y is equals to 1 by t1 into x plus at1. Let m1 be the slope. Let m1 be the slope of this tangent. Therefore, m1 is equals to 1 by t1. Now, equation of the normal at Q, at2 square comma 2at2 is, equation of the normal is y plus xt is equals to 2at plus at cube. So at t2, y plus xt2 is equals to 2at2 plus at2 cube. So this is equals to y is equals to minus xt2 plus 2at2 plus at2 cube. So this is of the form y is equals to mx plus c. Let m2 be the slope of this normal, implies m2 is equals to minus t2. Given that PQ is a focal chord. Given that PQ is a focal chord. Focal chord, the condition is T1, T2 equals to minus 1. From this, T2 is equals to minus 1 by T1. Right? Minus T2 is equal to minus of minus 1 by T1. So with minus I have multiplied on both the sides. Now what is minus T2 here? M2. What is minus T2? M2. What is 1 by T1? M1. So we got slopes are equal. Here, what is M1? Slope of this tangent. What is M2? Slope of this normal. Okay. So slopes, since equals to 0. So this implies 2 plus T1 into T1 square plus T1 T2 equals to 0 is what we need to show. This is the second question in which he is telling from an external point P, tangents are drawn to the parabola y square equals to 4ax, and these tangents makes angle theta 1, theta 2 with its axis such that cot theta 1 plus cot theta 2 is a constant d. Then show that all such P lie on a horizontal line. So this is a parabola. Next. So from an external point, draw two tangents. Draw two tangents. So this is from external point P x1 comma y1. So this tangent is making an angle theta 1, and this tangent makes an angle theta 2 with its axis such that cot theta 1 plus cot theta 2 is a constant. Solution: let P x1 comma y1 be a point on the required locus. So the equation of a tangent in its slope form is y is equals to mx plus a by m. So this implies y is equals to m square x plus a by m. Therefore, m square x minus my plus a equals to 0. Since P x1 y1 lies on m square x minus my plus a equals to 0. These are the tangents, and P lies on the tangent. Implies m square x1 minus m y1 plus a equals to 0. So this is the quadratic equation in M. Let m1 comma m2 be the slopes of these tangents. Then sum of the roots m1 plus m2 is equals to minus of minus. So y1 by x1 a square x plus by plus c equals to 0 minus b by a, sum of the roots, and the product of the roots m1 m2 is equals to c by a by x1. So here m1 is nothing but slope is equals to tan inclination, tan theta 1 plus tan theta 2 is equals to y1 by x1, and tan theta 1 into tan theta 2 is equals to a by x1. Now, consider cot theta 1 plus cot theta 2. This is equals to cot theta 1 can be written as 1 by tan theta 1 plus 1 by tan theta 2. This is equals to tan theta 1 plus tan theta 2 by tan theta 1 into tan theta 2. Tan theta 1 plus tan theta 2 is y1 by x1 by this is a by x1. So this is equals to y1 by a. And this cot theta 1 plus cot theta 2 is equals to how much is given? A constant d. So from this y1 equals to ad. Therefore the locus of p x1 y1 is y equals to ad. So which is a horizontal line. Therefore all such p lie on a horizontal line. Show that the common tangents to the circle 2x square plus 2y square equals to a square and the parabola y square equals to 4ax intersects at the focus of the parabola y square equals to minus 4ax. So what is the focus of this parabola? Minus a comma 0. So that point of intersection of the tangents, if we solve, then we should get a minus a comma 0, which is the focus of this parabola. Given parabola is y square equals to 4ax. Given circle is 2x square plus 2y square equals to a square. From this, x square plus y square is equals to a square by 2. So this is the standard form of the circle whose center is at the origin and radius is equals to r square equals to a square by 2, r equals to a by root 2. So center C is equals to 0, 0 and radius r is equals to a by root 2. Now, let the equation of parabola in its slope form is y is equals to mx plus a by m. So from this, m square x plus a by m is equals to y. Therefore, m square x minus my plus a is equals to 0. So this tangent also touches the circle. How do we know? Because this is also the common tangent of the circle. That means this tangent also touches the circle. So what is the condition for a line to touch the circle? R equals to D. R is the radius of the circle and D is the perpendicular distance from the center of the circle to the line that we get. So that implies R equals to D. So radius is equals to a by root 2 is equals to, what is the perpendicular distance from the center of the circle to this line? So that is modulus of m square into 0 minus m into 0 plus a by square root of square of the quotient of x plus square of the quotient of y, m square whole square m power 4 plus minus m square, that is plus m square, minus m whole square, that is plus m square. This is equals to a gets cancelled, root m power 4 plus m square is equals to root 2. Cross multiplication, squaring on both sides. That is equals to m power 4 plus m square is equals to 2 or minus 2 is equals to 0. M power 4 plus 2m square minus m square minus 2 equals to 0. M square into m square plus 2 minus 1 into m square plus 2 equals to 0. M square plus 2 into m square minus 1 equals to 0. Therefore, m square plus 2 equals to 0, m square is equals to minus 2. Therefore, m is equals to square root of minus 2 is not possible. Therefore, m square minus 1 equals to 0. Therefore, m is equals to plus or minus 1. Substituting m equals to plus or minus 1 in this equation. Y is equals to mx plus a by m. That is equals to y is equals to m is plus or minus x plus a by plus or minus x. So this is equals to plus or minus x plus a, y equals to. So what are the two equations that we are getting? Y is equals to x plus a and y is equals to minus x minus a. So this is x minus y plus a equals to 0. This is x plus y plus a equals to 0. So these are the two tangents, and the point of intersection of these tangents can be get through solving these two simultaneous linear equations. Solving x minus y plus a equals to 0 and x plus y plus a equals to 0. So subtracting 2x, a plus a is 2a, this is equals to minus 2a. Therefore, x is equals to minus a. Substituting x in any one of this equation, x plus y plus a equals to 0, minus a plus y plus a equals to 0. Therefore, y equals to 0. Therefore, the point of intersection of the tangents. Therefore, the point of intersection of the tangents is minus a comma 0. The point of intersection of the tangents is minus a comma 0, which is a focus of the parabola y square equals to minus 4ax. The sum of the ordinates of 2 points on y square equals to 4x is equal to the sum of the ordinates of 2 other points on the same curve. Show that the chord joining the first 2 points is parallel to the chord joining the other points. So let us take the parabola y square equals to 4x like this, and so let Pt1 comma Qt2 be the 2 point and Rt3 and St4 are other 2 points on the same parabola y square equals to 4ax. So let Pt1 comma Qt2 be the 2 points of a chord PQ, and Rt3 comma St4 be the 2 other points of another chord. Where Pt1 is equals to at1 square comma 2at1 Qt2 is equals to 8t2 square comma 2a into rt3 8t3 square comma 2a st4 is equals to 8t4 square comma 2a. Let us take the parametric points now. Equation of the chord joining two points P comma Q is 2 points form. Y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. This implies y minus, this is x1 y1 and this is x2 y2. So y minus 2a t1 is equals to y2 minus y1 2a t2 minus 2a t1 by x2 minus x1 a t2 square minus a t1 square into x minus x1 x minus a t1 square. This is equals to y minus 2a t1 is equals to 2a into t2 minus t1 by a into t2 square minus t1 square into x minus a t1 square. So a gets cancelled. So y minus 2a t1 is equals to 2 into t2 minus t1 by, this is a square minus b square, a plus b into a minus b. So this is t2 minus t1 into t2 plus t1 into x minus a t1 square. So t2 minus t1, t2 minus t1 gets cancelled. Therefore, we get a y into t1 plus t2, y into t1 plus t2 is equals to 2x minus 2a t1 t2. This is what we get. So y into t1 plus t2 minus 2a t1 t2 minus 2a t1 t2 minus 2a t1 square. This is 2x minus 2a t1 square. Minus 2a t1 square on LHS and RHS gets cancelled. Here minus 2a t1 t2. This is plus 2a t1 t2 we got. So therefore, this is equals to y is equals to 2x by t1 plus t2 plus 2a t1 t2 by t1 plus t2. So this is the form y is equals to mx plus c. Therefore, the slope of PQ is how much? 2 by t1 plus t2. Similarly, the slope of RS is equals to 2 by t3 plus t4 will get. Let us take the slope of PQB m1 and slope of RSB m2. And what is the condition given? The sum of the ordinates means y coordinates on y square equals to 4x is equals to the sum of the ordinates of other 2 points. So P is at1 square comma 2at1 is what we get. Take and at2 square comma 2at2. The first 2 points are this. The sum of the ordinates. So given condition is the sum of the ordinates, that means 2at1 plus 2at2 is equals to the sum of the ordinates of other 2 points. Other 2 points are RS. Their sum of the ordinates is 2a t3, because this we have taken it to be a t3 square comma 2a t3 parametric point. This is a t4 square comma 2a t4. The sum of their ordinates is 283 plus 284. This is equals to, if I take 2a in common and cancel throughout the equation, we'll get t1 plus t2 is equals to t3 plus t4. Without loss of generality, I do 2 by t1 plus t2 by is equals to 2 by t3 plus t4. Without loss of generality, can we do this? No. If you carefully observe, what is 2 by t1 plus t2 that we got earlier? M1. And what is this? M2. That means the slope of this M1 and the slope of this, which is M2, if two slopes are equal, they are parallel to each other. Therefore, PQ is parallel to RS is what we need to prove. Is parallel to the chord joining the other 2 points. So PQ is parallel to RS. If a normal chord a point T on the parabola y square equals to 4x subtends a right angle at a vertex, then prove that T equals to plus or minus root 2. So this is the parabola. Now let us suppose that at this point this is the tangent, for example. Then at P, this is the tangent at P. So the line passing through P and perpendicular to this tangent is this normal. So this is the normal. Let's take this point P of T, the parametric point a t square comma 2at. So if this is a tangent, the line which is passing through P and perpendicular to this tangent is this normal. Let this normal again intersects the parabola y square equals to 4x at Q T1, which is equals to a T1 square comma 2a T1. Now, this normal chord subtends a right angle at a vertex. So, for the parabola y square equals to 4x, what is the vertex? 0, 0, standard form of the parabola, whose vertex is at the origin. So, this is this chord makes an angle 90 degrees. This chord makes an angle 90 degrees at the vertex of the parabola. So, what is the vertex? 0, 0. So, this is given, this is 90 degrees. Then we need to prove that T is equals to plus or minus root 2. Solution. Given parabola is y square equals to 4ax. Let P T is equals to at square comma 2at be a point on the parabola. Since P is a normal, let this normal cuts the parabola again at Q T1 is equals to a T1 square comma 2a T1. Now, equation of the normal at PT is y plus xt is equals to 2at plus at cube. The equation of the normal at T. Since this normal is passing through QT1. That implies in the place of y substitute 2AT1. 2AT1 plus x is AT1 square. AT1 square into t is equals to 2AT plus AT cube. This is 2A T1 minus T plus AT T1 square minus T square equals to 0. This is equals to 2A into T1 minus T plus AT. This is T1 square minus T square is T1 plus T into T1 minus T. This is equals to 0. So this is, take A into T1 minus T as a common. Then this is 2 plus T into T1 plus T equals to 0. So either A into T1 minus T equals to 0 or this is equals to 0. This cannot be equals to 0 because T1 equals to T, but T and T1 are distinct points which constitutes a chord. Therefore, 2 plus T into T1 plus T equals to 0. From this, 2 plus T1 plus T square equals to 0. From this, T1 equals to minus 2 minus T square. Therefore, T1 equals to minus 2 by T minus T square by T is 1 by minus T. T square by T is minus T. Given that this normal chord subtends a right angle at the vertex. So, given that angle PAQ is equals to 90 degrees. That means PA is perpendicular to QA. PA is perpendicular to QA. So that means slope of PA into slope of QA is equals to minus 1. Product of the slopes is equals to minus 1 when two lines are perpendicular. That implies slope of PA into slope of QA is equals to minus 1. Slope of PA is 280 minus 0 by AT square minus 0 into 281 minus 0 by AT1 square minus 0 is equals to minus 1. This is equals to 280 minus 0. So this is 280 into 281. 2 2s are 4a square tt1 by at square into at1 square. A into a square t1 whole square. T square t1 square is tt1 whole square is equals to minus 1. So a square gets cancelled. tt1, this is cancelled. So this is equals to 4 by tt1 is equals to minus 1. This implies 4 is equals to minus tt1 minus t into the value of t1 is this minus 2 by t minus 2 by t minus t. This is equals to minus into minus plus t into 2 by t is 2. T gets cancelled. Minus into minus plus t into t square is equals to 4. So 4 minus 2 is equals to t square. Therefore, t is equals to plus or minus root 2 is what we need to show.